Alright, so we're going to finish up our exponential unit with our exponential decay. So remember growth, the formula f of t equals p1 plus r to the t. Decay is almost identical. F of t equals p1 minus r to the t. P was the initial amount. We get the letter P because it's the word principal, not like Chris Cook principal. It's an initial amount, usually talking about bank accounts and things like that. R is the rate, but you need it as a decimal. And T is time. Alright, so a new car in 1990 cost $20,000. The value decreases 16% each year. What is the value in 1996 and in 1998? So we know it's a decay because we have the word decrease. You'd be looking for decrease, depreciate, goes down, anything that describes a lowering of price or whatever. What is the value in these years? So we're going to get our equation. So we have f of t equals our principal, 1 minus r to the t, meaning we get f of t equals 20,000, because that was our principal, minus, or 1 minus 0.16, and then for the time, it depends on which one of these years we want to talk about. We're going to start with the first one. So that's 6 years after 1990. So we plug in 6 for t, 20,000. We get 84, or 0.84, to the 6th power. Again, we have a bunch of different things we can do with our calculator, a few different ones depending on the calculator that you have. On my calculator, I have the XY button right here. So I'm going to type in my base, 0.84 for x. Now it's going to ask for the power to the 6th. So I just did 0.84 to the 6th. We get 0.35. I'm going to take this whole number, multiply that by 20,000. And so in 6 years, this $20,000 car is now worth $7,025 and 96 cents. If we want to see at 8 years for 1998, do the same thing, but we bring it to the 8th power. So 20, gotta first do 0.84 to the 8th power times our $20,000 car, and it's 4,957, and then we're going to round to 2 decimal places, so 52. So 4,957 and 52 cents. So you can see in 2 years, it's dropped roughly $2,000, about $1,000 a year. But in the first 6, it dropped 13 grand. That's that decay factor. Start at 20,000 and very quickly you lose value, and then eventually you'll taper off, which makes sense because this car, no matter how old it is always going to carry value, even if it's just for the raw materials, for the metal that it's made out of. So it will never be 0. That's our horizontal asymptote. So a powerful computer is purchased for $2,000, but on average loses 20% of its value each year. How much would that be worth 4 years from now? So it's a very similar problem to before. We use our decay formula. We want to know at 4 years, so it's a $2,000 computer. 1 minus 0.2, 4 years. So we get 1 minus 0.2 is 0.8 to the fourth times 2,000. This computer after 4 years is only worth $819.2. Alright, so let's look at a few of them where we have to find something that's not the final amount. So we're going to be looking for the decay rate. We know everything but R. So in NASCAR, a typical car can hold 22 gallons of gas. If the car has 1.26 gallons after 70 laps, what is the decay rate? Alright, so talking about decay, so we're going to write down our formula. Time is actually going to be considered our 70 laps right here. Time. Principal was 22 gallons. We actually could take f of 70 out because we know what our total is going to be. It's 1.26. 1 minus r to the 70th. First thing we're going to do is we're going to divide by 22 on each side. So 1.26 divided by 22 gives us this. So we're going to take most of it. So 0.057 0.5727. That gives us 1 minus r to the 70th. So as weird as it is, we're going to take the 70th root of this. So we're going to take this number, take the 70th root, it's going to be this. So we're going to round that to 2 decimal places. So I found the 70th root. If you don't remember from yesterday, I have to use my square root like this, the same thing, base, and then pick my power. You can also, if you have the caret symbol on your calculator, you could take 0.05727, do the caret, and bring that to the 1/70th power. That is the same as taking the 70th root of this number. So we get 0.96 is equal to 1 minus r. I have to subtract 1, I get negative 0.04 equals negative r. Divide both sides by a negative, and our decay rate is 0.04 or 4%. Alright, so we just did a rate, so let's try a different one. So an adult takes some Advil. Each hour the amount of Advil in the person's system decreases by 29%. After 6 hours the amount of Advil still in their system is 51.24 milligrams. How many milligrams was the original pill? So we are looking for our principal. Still a decay. So we're going to set up our decay rate formula. So we know the final amount, 51.24. We don't know the principal amount. We know that this is going to be 1 minus 0.29, and the time is 6 hours. So we get 51.24 equals P. So this is 0.71 to the 6th power. So we're going to take 0.71 to the 6th power. Gives us this number. We don't know what the principal is, so I'm going to take all 4 of these digits. I know we've been rounding to 2, but since there's these double zeros, I'm just going to take these 4. 1, 2, 8, 1. We're going to divide by 0.1281. 0.1281. And that gives us our principal. So if I have 51.24 divided by 0.1284, is that right? 81, of course. We get 400. So the original milligrams of this Advil was 400 milligrams. So that is it for our exponential growth and decay. Use our formulas, plug in what you know, solve for what you don't. To get t, remember you have to take the t root of it, so whatever power it is, to get if you want to get rid of it. Those buttons on the calculator, excuse me, can look like this. This is the y root of x. You can also use the caret if you have that. I don't have the caret on my computer calculator. You might have it on your phone, you might have it on, you do definitely have it on a scientific calculator, for sure.